Hello my dear students, we are discussing the chapter indefinite integration. In the earlier modules we have seen how to evaluate integrals using the method of substitution, and we have seen some standard forms. Now to evaluate some more integrals we will require help of some more formulas. So let us see the formulas in this particular module. Now here we have been asked to prove that integral of 1 upon x square plus a square dx is 1 by a tan inverse of x by a plus c. This is one of the standard formulas which will require for integrals to be evaluated. Let us derive this formula now. My dear students, in the proof, let us see the first step. We are writing it as 1 upon x square plus a square. Now there are many ways of solving this particular integral. The simplest is, let us take a square common in the denominator. So what we will get here is a square outside the bracket, x square by a square plus 1. The basic objective is, the proof requires tan inverse on the right hand side. We are expressing the denominator in terms of tan inverse 1 upon 1 plus x square. That is how the tan inverse formula is. So let us do that. Now in the next step we can write that 1 by a square outside the integral, and we can rearrange to write integral 1 upon 1 plus x by a the whole square dx. Can I say that this particular integral is of the form 1 upon 1 plus x square? So we can write the answer as 1 by a square, which was there as it is, into tan inverse of x by a upon 1 plus, or can I say into 1 upon 1 by a, because coefficient of x is 1 by a plus c. Now my dear students, the a here and a in this a square will get cancelled to get 1 upon a tan inverse x by a plus c, and that is what they had asked for. Since this is a theory question, advisable to write the integral on the left. So we will get integral 1 upon x square plus a square dx is 1 by a tan inverse x by a plus c, one of the standard formulas. Now let us see one more. It says, prove that the integral 1 upon a square minus x square dx is 1 by 2a log mod of a plus x upon a minus x plus c. Now let us see this, student, how to solve this. So in this proof, let me write this as it is. Now my dear students, a square minus x square, we know it is of the form a square minus b square, and a square minus b square is, yes, a plus b into a minus b. So let us write this as a plus x into a minus x. Now my dear students, the problem we have here is denominator is having product of two terms, and we know how to integrate only addition of integrals, not multiplication of integrals. Okay, so let us see how to convert the addition, the multiplication in the denominator to addition of terms. Now my dear students, you need to observe a small thing here. The small thing is, if I add the two terms here, a minus x plus a plus x, if I add them, what I get is 2a, which is a constant. So now to convert the multiplication in the denominator to addition, we do a small adjustment. That is, we multiply divide by 2a to the numerator and denominator. Is that okay, my dear students? Now what we are doing here, we learn this in detail in the later modules. As of now, we'll keep it as it is. Now my dear students, in the next step, what we'll do is keep that 1 by 2a as it is, and instead of 2a, we will write a minus x plus of a plus x upon the same in the denominator, a minus x, a plus x, dx is as it is. Now my dear students, denominator is product, or I can say it is single term. So the next step is also obvious, separate. So in the next step, what we'll do is separate the numerator. 1 by 2a outside, and we have integral 1 upon a plus x plus integral 1 upon a minus x dx. Now let us write them as two separate integrals. So 1 by 2a. Now integral of 1 by x is log. So can I say log mod of a plus x plus log mod of a minus x upon minus 1, because coefficient of x in the second integral is minus 1. And do not forget a plus c. Now my dear students, what we have is something of the form log A minus log B, which is log of A by B. So what we can say is 1 by 2A log of A plus X minus log of A minus X, which can be written as 1 upon 2A log of A plus X upon A minus X plus C. And that's the proof. We have one more to go, and that you can take as a homework. So you have to prove that 1 upon x square minus a square dx is 1 by 2a log of x minus a upon x plus a plus c. These three standard formulas are to be remembered, so please practice them nicely. That's all we have in this module. Thank you very much.